Assalamu alaikum wa rahmatullahi wa barakatuh. Well, hello, my dear students. Welcome back to Algebra at the third preparatory stage. We will start lesson number 4 at Unit 2 in Algebra section. Lesson number 4 talk about operations on algebraic fractions. And this lesson we have 4 operations. We will start first with adding and subtracting algebraic fractions. Let's start. Example 1. Find nx in its simplest form, showing its domain. If nx equals the fraction plus this fraction, the first fraction x power 2 plus 3x over x power 2 plus 4x plus 3, the second x minus 5 over x power 2 minus 4x minus 5. We have here steps, constant steps. The first step, we will arrange each numerator or denominator, each one of the fourth, okay, with the greatest power in x. X power 2 of second, x power 1 of the first. Then it's arranged from the greatest to the small. That's right. And also this power 2, power 1 without power in x. Power 1, power without power in x. That means power 0. That's right. X power 2, power 2, x power 1, power 1. X not exists. That means x power 0 of 0 degree. This is the first step. You must arrange each one of the fourth. Okay, then we will arrange each one of numerators and denominators. The second step, it's also constant. We will get what? We will factorize. Yes, we will factorize each expression. Let's start. The first we have here common factor x. We will take it outside bracket and divide it by x. X power 2 divided x, 3x divided x equals 3, positive 3. Close bracket. Its numerator, okay, there is no common factor, but we have trinomial. It's factorized by 2 algebraic brackets, okay. X power 2 factorized by x times itself. 3, we will factorize 3 times 1, okay, and check your answer by getting the sum, because this is positive. 1 plus 3, 4. Yes, it's the middle term, okay. The greatest, take the middle term, the greatest 3, okay, take the middle term in its sign, positive, okay, and positive times positive is also positive. Okay, let's factorize the other fraction. X minus 5, there is no common factor, okay, and also it's first degree, that means it's factorized. X power 2, as x power 2, it's trinomial, as you see. Then we'll factorize it into 2 brackets. X power 2, x times itself, 5 times 1, okay. This is minus, that means 5 minus 1, 4. This is a middle term, exactly. The greatest is 5. Take the middle sign, okay. The middle sign, negative, it will be negative. Negative by negative is positive, okay. This is the second step, factorize. Step number 3, getting the domain or the common domain of the fractions, okay. How to get the domain? We studied before that the domain denoted by d, and our function is n. Domain of n equals r except or r difference, okay. R except the zeros of denominators. Then we will put each expression in denominators down, okay, equal 0 and get x. X plus 3 equals 0, then x equal -3. X plus 1 equals 0, then x equal -1, and so on. That means it will be 5, it will be -1, but it's repeated. Then I'll not repeat the number, okay? Are except -3, -1, and 5. This is the domain. Number 4, we will simplify each fraction, each one, in addition and in subtraction. If we add or subtract, plus or minus, we will simplify or reduce each fraction, okay? Then nx equals, how we simplify or reduce? By remove the common, yes, x plus 3, and also here x minus 1, that means it will be x and down x plus 1, that's right, plus up it will be 1 because we divided by the same number. X minus 5 divided x minus 5 equals 1, we will put 1, and down x plus 1. Hence we simplify each fraction. In adding and subtracting, we will turn to step number 5. That means we will unify. Unify what? Unify denominators. Demos. X plus 1, x plus 1. Oh, they are the same. Then they are unified. That means it will be x plus 1. Take any one of them and add the numerators. X plus 1. X plus 1 over x plus 1. They are the same. That means the answer will be 1. And hence we finished the lesson, the exercise. Another example. Find in x in the simplest form, showing its domain. And x equals x minus 1 over x plus power 2 minus x minus x minus 3 over x power 2 plus 6 minus 5. Let's remember the steps. If we add or subtract, we will turn to these steps. Arrange. It's arranged. It's not, because x power 2, x power 0, there is no x, and x. Then we will replace the two terms. How come? We will write x power 2 in the first, okay, minus 5x and plus 6, okay, and put the other one. X minus 1, x power 2 minus x, x minus 3. This is the function. We arrange it. Number 2, factorize. Let's factorize. We will factorize each numerator and each denominator. X minus 1, write it. X power 2 minus x. Yeah, we have here x repeated. Then x is a common factor. Put it outside bracket. X, and divide both of them divided by x. X power 2 divided x, x. Minus, x divided x, 1. X minus 3, and this is trinomial. We can factorize it by taking two brackets. Factorize the first and the last. X times itself, 6. We have here 1 times 6, or 2 times 3. Okay? This is positive. Take the sum. 1 plus 6, 7. 2 plus 3, 5. 5 or 7 in the middle, it's 5. Then we will take 2 and 3. 2 times 3 equals 6. And 2 plus 3 equals 5. The greets take the middle. 3 is a greet. Take negative. And negative by positive is also negative. They are negatives. Okay, this is the second step. The third step, domain. To get the domain of n, okay, we will write any fraction r except the zeros of denominators. Then I'll put each expression or each term, okay, equals 0 and get the value of x. X equals 0, then 0. X minus 1 equals 0, then x equals 1. X minus 2 equals 0, then x equals 2. X minus 3 equals 0, then x equals 3. These are the zeros of denominators, and this is the domain. After that, we will simplify or reduce each fraction of them. And x equals x minus 1, I have common factor. Then the numerator will be 1 over x minus x minus 3 common. Okay, it will be also 1 over x minus 2. The last step is simplifying. After simplifying is unify the denominators. The denominators here, x and x minus 2, they are different. That's right. Then I'll multiply them. Multiply them by what? By writing x and x minus 2 in bracket. Okay? And after that, I multiply this by this. 1 by x minus 2. 1 by x minus 2. Okay? This operation is subtraction, minus. And after that, I multiply 1 by x. 1 by x. Let's simplify numerators. 1 times x, x. 1 times negative 2, negative 2. Minus 1 times x is also x over x times x minus 2. X minus x, 0. Okay, then we will cancel them. Hence, negative 2, and here is x over x minus 2. Hence, we finished simplifying the function. But here, we want to find n3, n of 3, and n of negative 3. N of 3 and n of negative 3. Before getting them, okay, we must turn to the domain. We must look at the domain. Domain equals r except 0, 1, 2, 3. Then 0, 1, 2, and 3, the 4 numbers, these numbers is outside the domain, because the domain equals r except 0, 1, 2, 3. Okay, then n of 3 is undefined. It's not exist, because the function of n, the domain of n, okay, r except 3. 3 is one of them. But n of negative 3, we can put negative 3 in the simplest form and substitute in the simplest form of n of x. Okay? Yes, but replace x by negative 3. Then I'll put negative 2. X I replace it by negative 3. Bracket. X I replace it by negative 3. Then I write negative 3. minus 2. And getting the solution, negative 2 over getting this, negative 3 times negative 5, it will be 15. And this is the value of n of negative 3, as you see. Then n of negative 3 equals negative 2 over 15. And n of 3 is undefined because what? 3 doesn't belong to the domain of n. Okay. After that, we have one problem here. The problem is, if n of x equals x over x minus 3, and I want to get what? I want to get the additive inverse of nx. Additive inverse. Additive inverse will be negative nx. That means I'll change the sign of numerator or denominator. That means I'll change negative x over x minus 3 or x over negative x plus 3. I changed here the numerator. Or we can change we can change the denominator. Okay, I write x and replace x minus 3 into negative x plus 3. I change the denominator as you see. Okay, this is called the additive inverse of nx. Additive inverse, then I'll change the sign of numerator, or you can change the sign of denominators. Okay, and if we get the domain of n, it will be r except 3, r difference 3, and also the domain of negative nx or negative nx, yes, equals r difference 3 also. Then the domain of the multiplicative inverse of a function is the same domain of the original function. The domain doesn't change in additive inverse. And thank you for listening, and we will complete the other operations, multiplying and dividing, in the second video, inshallah.